All right, so today we're talking about introduction to functions. But before I get to that, I want to bring this up. So this is here a coordinate point. You guys all know a coordinate point. It has an x and a y. This actually another name for it is a relation. Okay, these are relations. So what we also know is that the y is an output, while the x is an input. Okay, so that's why it's a relation, because anything you put in, you will get out, and it makes a relation. So when you look at a dishwasher, if you put a dish in, you got a clean dish out, so therefore it's related, right? It's not like you're gonna put dishes in the laundry and try to get clean dishes that way. Although it might work, depending on if your dishes don't break during the wash. So anyways, there's another word for these outputs and inputs as well. So output, this is also called a range. Input is called a domain. So you're gonna see these two words quite a bit. Okay, so what is domain and range? Well, what domain is clearly my x value. So it really just means all possible x values. And the range is really all possible y values. Okay. So that's what I want you guys to understand. So in this section, you're going to get you're going to be asked to find domain and range. So what type of problems are you going to see? So you might see things like that you're given a set of points, let's say 3, 6, negative 5, 1, negative 3, negative 3, and 1, 1. Okay, so again, I told you that I was going to give you a set of points. So as a side note, these so-called squiggly brackets. Now, if you can't draw those are all because of practice. You can certainly do this. Okay, I'll understand that that's what you're trying to draw. This is, when you put things in here, it's called set notation. Okay, it's a set notation. So if you see squiggly brackets, that means it's going to give you a set of numbers or a set of points. Okay, in other words, many points or many numbers. All right, so it might have you from here, it's going to give you a set of points, and I want you to find the domain, and range. Okay? Okay, so the domain is all possible x values. So the domain, if I'm given points, is nice because I can read the x values off. In this case, I see 3, negative 5, negative 3, and 1. So I say negative 5, negative 3, 1, and 3. Now you're going to say, wait a minute, why didn't you write the 3 first and why did you write the -5 first? It's because whenever I give a set of something, I typically want to go least to greatest, all right? Now, if I look at the range, again, same thing with a set of points is nice because I can read these off. 6, 1, -3, 1. Okay, so the smallest one is -3. And then 1 and 1. So we do not need to write the 1 out twice. We just got to write it once and then the 6. Okay, even though we know that there's 2 1s, we don't have to write it twice. We just need to write it once. Okay, so that's how you will find the domain and range if you're given points. Okay, so how would you find it on a graph? All right, so let me do this here. Insert file. Let's start with something simple. So let's say a line. Okay, let's even shrink this a little more. All right, so let's say I was given this. So I'm given this graph. And again, it wants you to find the domain and range. Okay, so here's the way I look at it. First of all, in these graphs that you're going to see, it's going to kind of go off the graph. But really what it means is that there are arrows on here to say that it's going to go on forever and ever. Okay? So what I want to do is that because since the domain only cares about the x values, I think of it this way. Let me see if this will work here. I want to squish this until it's totally flat, just pointing left and right. Everybody see that? So I'm going to squish this so that it only points left and right, which is my x values. Okay? So if I did that, what happens? So if you notice, what did happen? Well, what happened was that it gave me this line, right? So this is my domain. All possible x values. So what is pointed all the way to the left? As far as humanly possible, it's negative infinity. What's to the right? Positive infinity. So therefore my domain is from negative infinity to positive infinity. Okay? And the way we would write that is negative infinity, comma, positive infinity. Okay. So if you notice that if we're given points, then we list points. But if we're given a graph, if you notice that because the line is connected, that means there is a whole lot of points in here. Okay? Some are fractions, some are decimals, right? Some are rational, some are irrational, but they're all real numbers. All right? So that's the way you gotta look at it. Okay, so let me erase those points there. So what we would do is write it as a range of numbers. Okay, so for the range, okay, so again, I'm going to do the same thing, right? Take this, and the range is all the possible y values. So what I'm essentially doing is taking this graph and squishing it as much as I can until it only points up and down. Well, when it points up and down, what is it pointing? Well, if I do this, what does that look like? It's going to look something like this. Right? So, notice my arrows turn green there. There we go. All right, so with that being said, so this is my range. So my range, same thing. It points down forever and up forever. So I'm pointing down forever and up forever. So my range is going to be parentheses, negative infinity, to positive infinity. Okay, doke. So now the next question is, well, next example. Let's do another example. So this was an example. This was an example. Let's do another one. Because now obviously we're not all the range and domains are going to be negative infinity to positive infinity. All right. So let's say it's here. Let's take another example and let's use this graph here, file, and let's do what we call parabola. So let me bring this over. Okay, so actually, we're going to shrink this a little bit, a lot bit. Okay, so let's say I'm given this as the given. Let me make it a little bit bigger. Okay, so we're given this, and we got to find the domain and range. And again, we know that these are arrows here. Okay. So again, domain. Domain is all the possible x values, right? So the domain, what I want to do is take this whole thing. Oops. I want to take this whole thing, and I want to just squish this, right? Oh, come on. Why won't you go any further? Come down. Nope. So you can only imagine what would happen, right? If I keep on going here, if I was able to keep on going, then what you will see is the result would be this again, right? So this would point to the left forever, point to the right forever. So therefore my domain would be negative infinity to positive infinity. Okay. Now, what about the range? Okay, the range is only the y value. So same thing, I want to squish this so that only points up and down. Notice where the two arrows are. Okay, the two arrows are on top. They're going to both point towards positive infinity. How about the bottom? Well, the bottom stops right here. So that's where it would start. Okay, so when I do this, I want to do the same thing. So let's check this out here. So what I'm going to have is something like this. Right? It starts here, and it's going to end at positive infinity, but it started at what? -3. Right? So here is where the question is going to start popping up, and you're going to be like, what the? All right, so range. The range is going to go from -3 to positive infinity. All right, so remember back in high school when you had open circles and closed circles, right? Well, with open circles, you would use like either a less than or a greater than sign, right? Where a closed circle, you would use a less than or equal to or a greater than equal to sign, okay? So here, we're essentially doing the same thing with open circle and closed circle, because since we are never going to touch positive or negative infinity, that's the reason why they have parentheses. But if it does touch, like this is touching -3 right here, so therefore, I'm going to use what they call a square bracket. Okay? So again, when it touches a number, then it's going to be a square bracket. If it never touches, it's going to be an open bracket. Okay? So that is the way we would do range and domain and range. Okay? So next question is, what What if we had something more like, oops, insert, a circle? All right, so shrink this a little bit. Shrink this more. So what if we're given this? Okay, what if we're given this? So same thing. I'm still gonna do exactly the same. So I'm gonna take this. Domain is all the x values, so I want to squish this so that it only points left and right. So if you look at this, it's gonna flatten out, right? So it's gonna give me something like, not that, but I'm gonna fix it. It's gonna go from there to there. And it's gonna touch those 2 points, isn't it? Okay, so therefore my domain, so where are those 2 points? This has an x value of -4, and this has an x value of 0. Okay, again, we're talking about x values here. Okay, so if I was to plot this point right here, this would be what? 0, -1, and this point would be -4, -1. Okay, so all I want is the x value, because domain means the x values. All right, so that's the reason why I would pick that. All right, so when I write this out, it's going to be a square bracket since I'm touching -4 and I'm touching 0, so it gets a square bracket as well. Okay, so let's look at what the the range would look like. Okay, so we're going to do the range. So let's take a look. If I squish this all the way down in, what is it going to give me? Okay, so let me try to line this back up here. Okay, so what am I going to get? Well, I'm going to get something like this from here to here. Okay, and it's going to touch that point and it's going to touch that point. Well, what's this bottom point? Bottom point is -3 and the top point is 1. Okay, so let's look at that. All right, if you look at this, now we're looking for y values, right? So this point right here is what? It is -2 comma -3. And this point here is -2 comma 1. Okay, so why did I use the -2 and use the -3? Why didn't I use the -2 but I used the 1? Okay, so again, the range is only the y values. Okay, so that's why I used the y values. So the range, since it touches -3, it starts there and it goes to 1 and it touches 1. So they're both square brackets as well. Okay, so hopefully that will help you. Now, to know if these graphs are functions or not. So I want you guys to think about this a little bit. Move this over and call this example. Okay. Is the relation a function? Okay, so to know if it's a function or not. Function means, so if I put 30 dishes in my dishwasher and it doesn't come out clean, then my dishwasher is clearly not functioning correctly, right? So therefore, I know it's not functioning or it's not a function. But if I put in dirty dishes and clean dishes come out, then I have a function, a functioning dishwasher at least. Okay, so but with this being said, again, we were given what to find domain and range? We were given points to find domain and range, and we were given graphs to find domain and range. So for our function, it's going to be the same idea. We're going to have to know how to see if given points are a function and if a graph is a function, okay? So it's pretty easy. So for a graph, we're going to use something called the vertical line test. Okay, what does that mean? It means that if I was to take a vertical line and if I was to take it and place it anywhere on the graph, and I can cross the graph more than one point, is not a function. So this circle is not a function. But you could say, well, but what if I move it out here? You're right. But bottom line is that we're trying to prove that it's not a function. Okay? So we're trying to look for things so that it would tell me that it's not a function. It's kind of like, you know, in a relationship when you kind of think that your significant others might be cheating on you, you're not going to just look at one source and say, well, it doesn't touch, so therefore they can't be. So you're going to try to keep on looking and looking and looking until you find something, okay? Now, in this case, it only crosses once, okay? Since it only crosses once, then this is a function, all right? So if it crosses more than once, then it's not. All right, so let's take a look at, undo. Why is the last one not working? There we go. All right, so if we look over here, same thing. We look, nothing, okay? So that's a function. So this right here is a function. This right here is also a function. This right here, again, where I can look, there is a place where there's none, there's a place that's there 1, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 1, and then none. So in this case, this is okay. So there we go. So that's not a function. So we need to remember that. Okay. So with graphs, it's pretty easy. Okay. But what about with points? Okay. If you think about this, this is actually a pretty easy thing. Let me draw that line again. Not a very straight line, not very vertical here. Okay, so let's say that I put it right here, okay? So let's think about this. That's a bad place to put it because you can't read nothing. You know what? I'll just put it right there. Right in the center here where, you know. So if you look at this, there's my 2 points, right? I have this point right here, which is, I wrote out already, -2, 1. And I have this point right here, which I wrote out, the point is -2, -3. Well, those 2 points, if I was given those 2 points, it would tell me that it's not a function. Well, if you look at those 2 points, what shows up? Oh, the -2 shows up, right? If you look at the top point and the bottom point, both the x values is -2. So that's how you know, wait a minute, That's not a function, okay? So let me undo a couple of things here. Undo, excellent. So now I can just take that away. So with points, if the x repeats, not a function. Okay? Let me do this. Bring this down to here. And let's put an explanation here for this one. So if vertical line crosses graph more than once, not a function. Okay? So there you go. That's how we tell if a relation is a function or not. All right? So the next thing they might tell you, so we know how to find if it's a function or not, we know how to find domain and range. What's the next type of equation they're going to give you? So let's do this. Let's insert this right here. Okay, so it's going to tell you so this is what they're going to give you. They're going to give you f of x is equal to that, and g of x is equal to this, and h of x is going to give you this. Okay, so in other words, it's going to give you three different equations, and basically the f of x, g of x, and h of x is the way it's called the function notation. So if I had so f of x is equal to 3x plus 3. Well, that is the same thing as y is equal to 3x plus 3. Okay? So this would be called the function notation. Okay? Let me see here. Okay. All right. So this is called a function notation. Why are we using function notations? The reason why we're using function notation is because if I was to tell you, hey, y is equal to 3x plus 3, y is equal to negative 2x squared minus 3x plus 4, and y is equal to 2x squared plus 2, and I said, okay, find y when x equals negative 2, right? So you're either going to give me one answer, you're going to pick an equation and just plug that x of negative 2 in there, or you're going to give me three different answers. But I only want one. But you got to figure out which equation I want to pick. And this is the reason why function notation came about. All right? So what they did was say, okay, instead of doing it that way, we're going to call this f of x, g of x, and h of x. Okay? So the f, g, and h part, it really doesn't matter what letter you use. You can call it s of x, b of x, capital C of x, z of x. I would recommend not to calling it x of x or y of x, but this would be your so-called function notation. Okay, so if you notice, the only difference is that I replace y with f of x. That's all it was, right? If I replace y with f of x or g of x or h of x, I just converted a regular equation to a function notation. That's it, all right? So now with that being said, it wants me to find g of -2, okay? So if you notice, so first of all, this right here, the g is calling for the g function, okay? So let's see here. Let's use this a little bigger. So the g here is looking for the g function. So that is the function I use. I don't use the f or the h. That is the equation it's calling for, okay? So that's number one. So now I know this is what it's calling for, okay? So what's the difference between g of -2 and g of x? If you notice, the only difference is that part right there. So all it's saying with g of -2 is wherever the x value is, replace it with -2. Okay? That's all it's saying. So therefore, the g of -2, is equal to -2. So this is, again, what I would do. Wherever you're supposed to put in the x, put parentheses around it. So -2, -2. So now I got to do the order operations, right? So this right here, however, is going to stay put. This is not g times -2. It's just a g of -2. It's just a notation. What is the y value when x is equal to -2? That's all it's saying, okay? So that stays put. So then you're going to work the right side. Well, order operations. So I got -2 times 4, because -2 squared is 4, minus 3 times -2 plus 4. And then I multiply -8 plus 6 plus 4. So g of -2 is equal to 2. All right, so it's -8 plus 6 is -2. -2 plus 4 would be +2. Okay, so that is something else that they could be asking you to do. All right, let me see, what else do we got here? There is one more thing. Okay, so that's not too shabby. So here's my next question. What if let's use that. Okay, so let's bring this over here. So we're given this wonderful graph. Okay, and so here's the thing. If you're given more than one graph, they're going to typically label these as function notation as well. So they might say, hey, this is what I call f of x. Okay, so if there's another graph there, they're going to call it g of x. If there's a third graph on the same graph, they're going to call it h of x. Okay, so let's say over here they tell me to find f of 0, which means, again, what is y when x equals 0? Okay, so that's all it's asking. Okay, what is y when x is equal to 0? So if I was to look at this, I'll say, okay, here's my x being 0. So I gotta get to the graph, and there's my point right there. Now, if you look at this point, what's that point? That point is 0, comma, -3, okay? So, look at that. X is equal to 0. My Y value is -3, okay? Everybody see that? Hopefully everybody does. So, then f of 0 is equal to -3. Okay, what if I say find f of -2? Okay, so another way of thinking about it is, again, using that vertical line would be a good idea. Actually, let me do it with this. So I bring this to -2. Where does it meet the graph? It meets the graph right here, right? So what's my Y value at that point? 1. So it tells me that f of -2 is equal to 1. Okay, so you guys can do this all the time and say, okay, so if I had f of -1, that's -2. F of 1, that's -2. F of 2, that's +1, right? What's f of 3? Well, we're not really sure because it's off the graph, okay? So that is some of the things that you could do to figure out what's the easier way of doing this. But that's how you would think about doing it. Or you could just do this, going, okay, I got my graph. I can read this point. That is -2, 1. This is -1, -2. This is 0, comma, -3. This is 1, comma, -2. And this is 2, comma, 1, right? Now you know that the f of -2 is 1. F of -1 is 2. F of 0 is -3. F of 1 is -2. F of 2 is 1. Okay? So that is something else you could do as well. Most likely they're going to ask you for things that you can read. And not just like fractions of it, okay? So these points may not be given to you overall, but you can always find them. All right, so there we go. All right, so those are the different things that they're gonna ask on the homework assignment. I hope this helps you. If you need to get a hold of me, you know how to do that. Thank you.